Okay, so let's try working through this problem. Here I have a multi-loop circuit. And by the way, you have a homework problem like this as well. You could conceivably see a problem on the test, just a plain multi-loop circuit, but it's going to be made simple so that there will not require solving a system of 3 equations, which can be kind of time-consuming, right? Like we're going to do here, and I wouldn't require that on a test, but we'll see some examples of problems like you should encounter. But you need to know how to do this in order to work those problems. So let's look at this circuit. First thing I want to do is just pick some currents, directions for currents. I'm just going to choose, let's see, I'll choose this to be I2 in this direction. I'll choose I1 to be in this direction, and then I'll choose I3 to be in this direction. All right. Now I want to write the 3 equations using the loop and junction rules. You need to choose 2 loops because I have 3 unknowns, the 3 currents. You need to choose 2 loops and then the junction rule. So you can either use, in this case, the top loop and the bottom loop, the top loop and the big loop. You get it, just 2 loops out of the top, bottom, and big loops. Let's use the upper loop. It doesn't really matter what you choose. The upper loop, and I'm going to start here and go in this direction through the circuit with the current, and then I'll follow through doing the potential difference for each of these. So this is going to be 10 volts minus 6I1 plus 14. That's up here. I've come up here. I'm gaining energy. Minus 4I2. And that's equal to 0. Now I'm going to choose the lower loop. Excuse me. And so for the lower loop, I have, I'm going to start here again, going in this direction. I have 10 minus 6I1. It's the same as for the previous. But then I'm going to come down here, and that's going to be minus 2I3. So notice how I've applied those simple guidelines for the directions and the signs of the current, or rather the signs of the changes in potential or voltage for each of these. Right? And then I'm going to do the junction rule. It doesn't matter which junction you choose, because since there are only 2 junctions, they're going to have identical equations. The current in will equal the current out for both of those. On one junction, what was in will now be out. So it doesn't matter which junction you use. Let's see. I'll just use this junction over here. The current in is I1. The current out, see, leaving in this direction and this direction, is I2 and I3. All right, so now I have a set of 3 equations, and I'm going to solve equation 1 for I2, and then I'll solve equation 2 for I3, and then I'll plug those into the junction rule equation. So let's solve equation 1 for I2. So that's that first equation. If I do that, I find that I2, let's see, I have 24 minus 10 let me start over here. So I have 24 minus 6I1 minus 4I2. And I'm going to solve that for I2. So I have I2 equals 24 over 4 minus 6 over 4 I1. And that will be equal to 6 minus 3 halves I1. That is going to equal I2. So that's one equation. Now I'm going to solve equation 2. the second of the equations, I'm going to solve it for I3. Just go ahead and rewrite that equation 2 over here. That was 10 minus 6I1 minus 2I3 equals 0. Remember that was from the lower loop. I'm going to solve that for I3. So I'll take this over here and divide by 2. It's going to be 5 minus 6 halves, or 3I1, is equal to I3. I just added 2I3 to both sides, and then I divided both sides by 2. And I get this. All right? Now, I have these two substitutions, and so I'm going to take my junction rule and plug those both in to my junction rule. My junction rule equation said I2 plus I3 is equal to I1. That is that I1 is equal to I2, which is also 6 minus 3 halves I, 1, plus I3, which is 5 plus 3 I1. So see, I've just substituted these in for I2 and I3. Let's see, I have a mistake here. Yeah, this should be 5 minus 3I1. Okay, now I want to solve this for I1. So just to simplify this a little bit, I have 6 plus 5 is 11. Negative 3 halves minus 3. Let's see, that's negative 3 halves. Negative 9 halves. I1. Okay. And if I add 9 halves to both sides, that's going to be 11 halves I1 equals 11. So I1 equals 2 amps. All right, so that's my first answer. And if you notice, if we go back to our I1, we had I1 going to the right. And so the direction for I1 is also going to be to the right, because that's how we had it drawn initially. Let me show you. So I1 right here was drawn to the right, and so it is that since the current came out positive, then we knew that direction was correct, and so it is also to the right. Now, when we want to find I3, I know what I1 is. I1 is equal to 2. And so I can just come up here and I can say I3 equals 5 minus 3 times 2, which is equal to negative 1 amp. Right now, I3, we chose to be like clockwise. So the direction for I3 is going to be 1 amp counterclockwise, which is the opposite direction from what we chose. And then if we want to find I2, we can come back to our original equation right here, or the first equation we did. We know I1 is 2, so that's going to be 6 minus 3 halves times 2. It's going to equal I2, which is 3 amps. So I2 is 3 amps. We chose that direction to be counterclockwise, and so it is also counterclockwise. So we chose our directions correctly, except for this I3, which should be in that direction. And we know that because I3 came out to be negative. All right, that is a multi-loop circuit, and we'll see some problems where you have to discern the appropriate equation using either the loop rule or the junction rule. And then we'll also see some circuits that are multi-loop circuits, but they're a bit simpler than this because they have fewer unknowns. And so you don't need to solve the whole system of 3 equations in order to figure out what is the current. You know, you can solve these systems of equations with an algorithm, a computer algorithm that's pretty simple. I mean, you can even program it in Excel to solve a system of equations. And I think even many of your calculators will do this. But it really makes solving much more complicated circuits very easy. You could have a circuit that's described by 1,000 equations or 1,000,000 equations or however many equations you need. And you can solve for the current at every position within that circuit. So that's really useful, and it has a lot of applications in various things. All right, so let's take a break there. Here's a question asking the following equations. You'll see this on the quiz. Also, I give you a current, and I ask you what is the magnitude and direction of another current. So that's quite a bit simpler because one of the currents is now known, and you just really have to pick the correct equation, and it becomes quite simple. Here's another circuit. This one's easy because this bottom loop has no resistor in it, and so it makes it quite a bit easier. But I'll leave that to you to play with, and you'll see that on the class quiz. A few more. Goodness, a lot of these. Did I just skip through all those? Okay, no. All right. All right, we will pick back up with RC circuits soon.